mag-record sa cloud. Okay, so good afternoon. So our previous topic was your assignment. This one, di ba? Mabili niyo ang assignment the last time.
Yes, sir. Mauna.
Okay, so dapat your assignment should be the final formula for your assignment should be theta 1 and theta 2. Okay, so this time, when the number of degrees of freedom increases or the number of joints increases, so there is a need, no? There's a need to come up with this matrices, no? Kinematics matrices as presented during the orientation, particularly in the programming of using MATLAB. So it is using matrices. So specifically, object location and motion, transformation matrices, homogeneous transformation, and so on and so forth. Okay, so next. So object location and motion. So how are we going to represent the location of the object as well as the motion? So when you say object location, so this is the position of the point in space as well as the location of a rigid body in a space. Okay, so later it will be shown that it can be represented by transformation matrix as well as the object motion, no? Aside sa location sa imong object, then that object is being moved as well in the space. So that's why there is this translation. So there are two types of motion of the object. This is translation and rotation. Okay, so example would be in translation, it will be dealing with translation matrix, and for the rotation, we'll be dealing with combination of translation and rotation matrix as well. Okay, so why is it that there is this object location and motion? So actually, we are referring to the TCP, no? Sa TCP nato, if we have a tool, then there is what is known as a tool center point. Katong specific na tool, no? What is specific na tool? Example will be our object location as well as its motion, as the TCP or the tool itself, no, for our manipulator is going to move. So how are we going to represent that in matrix na general na kinematics na format? Okay, so given an object in a physical world, how to describe its position and orientation. So it's not just the coordinates we're dealing, but we're also describing its how it is being oriented. Is it rotated? Rotated ba siya by a certain degree? So at least the orientation, how it is being positioned in the space, and how to describe its change of position and orientation due to motion. So mo gina ang general objective nato na given an object in the physical world, man silang duha na question. Then the term location, no, refers to the position and the orientation of the object. It's not that one lang coordinates lang niya sa iyang position, but rather what is its orientation? Nakatilt ba siya? Or kung ano ba siya, perfectly horizontal or vertical? Malinana naman ang examples. So coordinate frames. So if P, kaniya to ang point na to in the space is a vector, no? In dimensional space R to the n, no? And X, which are the a set of axes or the coordinate system x1, x2, x3. And so on and so forth, be a complete orthonormal of Rn. So this is referring to the axis, no? So in this case, it is being generalized lang. Pwede na imong x1, x2, x3, pwede rin na siya x, y, o z. Okay? But in mathematical na representation, ginani siya. Kaya it's possible na you could have more than 3 axes in your coordinate system. Then the coordinates of P with respect to X are denoted as vector P to the n and are defined as siya. Just the formula lang. Your P is the summation, not your vector P, no? Times X, no? Kanimong axis. So the complete orthonormal set X is sometimes called orthonormal coordinate frame. Okay? So that's why makakita mo term sa tuang laboratory, no, ng reference frame. Ano siya? So actually, we're not just dealing with a basic lang na coordinate, but rather it's a frame. Gina-frame siya. Okay, coordinate frames. So the cape coordinate of P with respect to X is siya. No? P scalar dot product of the coordinate unit vectors, no? So example, let's say kaning imong vertical is x2 or pwede y, no? Pwede ra butan lang ito na x2. Then imong horizontal is x1. So kaning red nimo na vector P, manay mong point is not just a simple na point, kay pwede mo gadang imuhang object na pwede mong siya na high position as well as ang iyang orientation. That's why it is now being represented in vector form. Pag may vector form, na siya ay direction and magnitude. Naka-learn ba mo na sa kuan? Sa inyong calculus or physics or sa ba ninyo na subject? What is a vector? Guys, kadamtom ba mo what is a vector? It has both magnitude and direction. Regnana siya by principle. But in this case, ang ato ara is kining kuan iyang projection, no? So therefore, with respect to this formula, what is now the projection of your P along x1 or horizontal axis? So therefore, you just simply get the dot product. Okay? x1. This point with respect to x1. Then if you're going to get the projection of P with respect to the x2 or vertical axis, so P dot x2. So, it's a may kadumdum sa inyo, what's the formula of that product? Naikabalo sa inyo formula sa dot product. Okay, so mag-google tanong. What is a dot product? So dot product. Okay. So, kanin ko lang, Wikipedia para generic. Makita nyo guys ako ang kuhan, Wikipedia. Makita nyo, this is a summation. So kato siya ganiyaman, ito siya, the formula. That product is a summation. But specifically kani, okay? So kaning gi-highlight na to, A dot B. So A is a vector, then B is a vector. So we say A dot B or A scalar product, dot product to B is equal to the magnitude. Pag may hanggang na absolute value bitaw. So magnitude of A times magnitude magnitude of B times the cosine of theta between the two na to vectors. Example kanina sa kilid. So let us say x, no? So x ug y, so ang ilahang duha ka vector, ang ilahang angle mo na ang imong butangan nimo og cosine theta. You're going to determine the cosine theta. So diri pa where theta is the angle between A and B. Okay, so cosine siya ha. So kung nakadumdum mo atong inyong assignment, makita na niyo atong PowerPoint. Kung kadumdum mo sa inyo assignment, kani diri dapita naman ay angle diri na theta, no? So the angle between the vector P and kaning imong axis na x1 is assumed nato na theta. So therefore, wow nimong projection niya diri is that is P, no? P cosine theta, no? So pareha ra siya sa formula sa katong. Ang formula niya is kuan man, the magnitude of P, no, times the magnitude of the unit vector. Since unit vector man siya, 1 naman siya. Unit naman. So 1 dayan times the angle cosine theta. So therefore, itong assignment niya diri is P cosine theta, dapat siya diri na projection along this horizontal na line. And the same is true pag diri po sa PCAS, ang angle na po niya diri sa PCAS is diri ra gyapon. Diri sa PCAS ang iyang angle. So ay laser. Let's say diri na po is beta, no? Beta ni diri. Then diri kiniya is theta. Theta na din. So diri na po, if you're going to get the projection of vector P along the vertical axis or x2, so i-dot product na naman siya. So bali, ang equation ni Ana ron is P times cosine of beta, because the unit vector x, no, x of 2 is just 1 naman ay value. So mara na siya ba? This is just a general lang na presentation. Okay, so next, may pangutahan na ito. Yan sa ni pag-represent. Okay, so kung wala, then let's proceed. So given an object in the physical world with point P. So ano eh? Ano itong P diri? No? Now, based on the formula, we have this, no? The vector P, no? Where K is equal to 3. 1, 2, 3. Tulo man siya. Then, with this coordinate frame na M1, M2, M3. So, ang buhaton na nimo is just simply apply the formula P.M1, P.M2, and P.M3. That represents now your vector P. Ano mo ang point diri. Okay? So, kaniya tong object is rectangular. No? Rectangular siya na object. Dayon, the question is, why is it letter M? Ano sabi ng letter M? So actually, the letter M now symbolize the mobile frame. Okay? So when say mobile frame, ano ang frame na nasa mong TCP? Tingala mo atong ipamove ninyo, atong mag-drawing of rectangle ba? Magliyok-liyok ang imuhang TCP na reference frame. Meaning sometimes the TCP is not aligned with your base na reference frame. So mo to siya, no? So kaning imuhang mobile frame could be an example of a TCP, the toll center point. Okay, TCP nimo. TCP. Okay, mo na yan tunga dire. Okay? Pero mo na yang it's possible that Ito yung imuhang kuha na ron, imong object na gigunitan sa imong tool. Yung tool nimo na siya object, siya gripper na ang iyang position, reference na position natin na rin. No? So, mo ni representation in matrix form. Now, what will happen kung i-rotate na to ang mobile frame? No? So, what is now the new values of our matrix vector P or P? Anybody could guess? Guys, what is now the representation of P in matrix to form? Gituyok man siya, di ba? Nabala ni nakita niyo na nagituyok ang imuhang object. Tuyok siya wala. Ni-rotate siya wala.
Ni-rotate, sir.
Okay, very good. The question is, what is now the vector? What is now the matrix? No? Matrix the form sa imuhang vector, sa imuhang P vector.
Ang M. Ang king nasa ibabaw.
Okay, so it's the same thing. Kaya nga ang pangutana ng the same raman sila, sir. The same raman.
Okay, same naman sila, sir, na rotate lang.
Okay, very good. So mo na ang pagsabot sa to ang pagsabot sa to ang formula sa to ang scalar dot product. I-apply nimo ang dot product kana mo ra gyapon. Ang M2 na gyapon diri, ang M1 na gyapon diri. Okay? So walay na usaba. So take note that is for the mobile frame. But if that is in reference to the fixed na reference frame such as the base na mausap siya. Okay? So take note this is just for the mobile frame na reference kanya ng M. Pero kung base na siya na dili na siya pre value. Okay? Kasi nabuta wala. Okay, so let's continue. Represent position of P with respect to the fixed frame. Okay, wala din ako na-edit. Sorry. F1, F2, and F3. So, mani. So, kaning sa ubos na to, mani itong base. Now, let's assume that this fixed na link is our base. Agree, disagree. Base din sa to ang manipulator. Okay? So this is a fix. So manang F1, F2, F3 fix na sila. Hindi siya magliyok-liyok. Now, nanong naaman ni object diri sa to ang fixed frame? Guys? Ano na naman ang object, ang mobile frame na to sa to ang fixed frame? Okay, so this is an example. Kaning fixed frame na to, mo na to ang robot na base. Ang base by default is fixed man na siya. Magliyok ba ang base sa katong inyong laboratory sa RoboDK or katong naka-actual na sa
Dili, sir.
dili siya mo liyok, di ba? So fixed gid siya. Whereas kaning imuhang mobile frame mo niya to ang nasa gripper kung magbutang tag object sa gripper na to. Ano siya na senaryo, no? Pwede na siya mabalin-balin. Now the question now is, what is now the vector P represented in in the fixed frame? So inani magyapon, simple lang formula. P dot F1, P dot F2, P dot F3. By the way, never mind the kanang na superscript ba na siya na subscript, it's just a notation lang siya. Okay? So never mind na. Basta as long na you follow the format, kaniyang format to. Ang kaning sa ibabaw niya superscript is siya, it's the fixed frame. Sumana siya. Okay? Now, if it is with respect to the mobile frame, namuro po siya. Okay? So nakita niyo ang difference now? Kung kuhaan mo ang vector P in matrix form that is with respect to the mobile frame, magyapon ang gamito nimo no, i-dot product na nimo siya kung asa ang iyang unit vectors such as M1, M2, and M3. Pero kung pangutanon ka with respect to the fixed frame, i-dot product nimo siya sa fixed frame. And equal ba kaning duwa, kaning vector P with respect to the fixed frame? Is it equal to the vector P with respect to the mobile frame? Pareha ka sila result, dili. Guys, pareha ka sila? Dili sila pareha. Okay? So dili sila pareha. Okay? Ang kaning imo ang kuan mobile frame nam si kagalingon niya coordinate frame, di ba? Dayon kung kaning imong kuan kini po ning imong fixed frame na ba siya kagalingon niya na kuan na coordinate frame. Mag-equal na sila kung aligned ang M1 to F1, align ang M2 to F2, and align ang M3 to M3. Okay? So mag-equal na sila. Okay? Agree, disagree? Okay? Pero kung in this case, dili na sila align, dili na sila equal. Okay? So, the two sets of coordinates of PR. So, maram to ganiya, no? Ibalik-balik lang niya. So, the coordinate transformation problem is to find the coordinates of P with respect to F given the coordinates of P with respect to M. Asay given sa duwa bay, kining primero kining ikadua.
Kanang nasa pinakauna, sir.
Okay, so maning ang given is P with respect to mobile frame. So man ang given. So ang ato ang ultimate na kuan na isolve is ang kaning vector P with respect to the fixed frame or kanitong base sa robot. Okay, so man ang ultimate na kuan na objective. Man ang gitawag na coordinate transformation problem. So how is it being converted from one coordinate system in every joint of your robot naman na siya gitawag na coordinate system. Ano na siya XYZ. So mana ginat-transform siya from the TCP dayon padong sa joint 6 transform siya dito din. Ang transformation na po dato ito na po sa joint 5 until moabot ka sa imong joint 1 or theta 1 na reference frame. Okay, so inana siya ano siya ang ultimate na problem, okay, in dealing with this kinematics or coordinate transformation. Okay, so naakay let F be the fixed frame set of axis, then let M the mobile frame set of axis po M1 to M1 be the coordinate frames of dimensional space in Rn. With F being orthonormal frame, then each point in Rn is defined as may mo na siya. So, pag ma-notice ninyo, kanus lang siya ma-equal, no? Ma-equal lang siya kung ma-equal lang sila kung ang imong mobile frame is naka-originate sa imong fixed frame. But most of the time, dili na siya metabo. That's why the reason is known as kaning A. Nakay multiply sa imong na-factor na A na matrix na multiply para mag-equal sila. And in fact, that is what is known as A. Before that, this is an n by n matrix. So, dili siya pwede na square matrix kasi dili siya pwede rectangular. And take note, the A is F dot M. So inana na siya yung formula. So technically, this is now what is known as the coordinate transformation matrix. Okay? Para ma-solve nimo si vector T with respect to the fixed frame given si mobile frame. Given na siya dapat. Kung wala ka kabalo, asa na siya. So, lisod po. Wala given. No? Dayon, ang imong solvon is kaning coordinate transformation matrix, pag multiply nimong duha, masolve na dahil nimo yung fixed frame na vector point. Okay. So, mara ginani guys. So, gani ha. So, fix 1, frame 1 times M1. So, mano yung, so, according sa formula ganiya, okay? So, mano siya. Okay, so dot product siya. Explain naman na ito ganiyang dot product is actually the dot product of the unit vectors. So, nasa cosine theta angle between. Okay? So let F and M be two orthonormal coordinate frames in a dimensional space in Rn, and let A be the coordinate transformation matrix that maps M coordinates to F coordinates. Then the transformation matrix which maps the coordinates into is given by inverse po ni. So na po siya relationship, no? Actually, you can always solve for the inverse matrix. You can Google the formula for inverse matrix. But in this case, it is also equal to the transpose. The inverse matrix is just equal to the transpose. So, ano yung isa ka characteristic. Okay, so A of 1 is what is known as the inverse transformation matrix. Okay, so example, rotation. Nakabantay mo guys. Na kaning sa imuhang kanina example na mobile frame is that wala siya sa origin sa imong fixed frame, so distansya siya. At the same time, it is being rotated, di ba? So in order to specify the position and the rotation of the mobile tool or katotong giingon na TCP, the tool center point in terms of the coordinate frame attached to the fixed base, so na ito ang reference base, ito ang robot. Coordinate transformation involves both rotations and translations. Okay? Kinanglan ng dua. So, let's consider first fundamental rotation. So, pag mingon kag fundamental rotation, marami ginani guys. Atong assumption na ni default is counterclockwise sila tanan. Okay? So, if the mobile coordinate frame is obtained from fixed coordinate frame F, by rotating M about one of its unit vectors of F, then the matrix is called fundamental rotation matrix. Okay? So, ang isa fixed. Ang isa is fixed na along the fixed frame. Dayon, i-rotate. Pag-rotate niya, kaning imuhang M2 and M3, mo rotate. Pero ang fixed niya, ang isa lang ka, mong access, no? So mo nang gitawag na fundamental rotation matrix. Pwede po tinanin ang M2 pwede mo rotate, so by default counterclockwise atong notation. Okay? And pwede po ang imong M3 mo rotate, then ganing M1 ug M2 mo tuyo. Okay? So inana kung tulo na sila. So example, asa mo na siya gipatuyo? Where is our fundamental rotation? Sa M1 ba? Sa M2 o sa M3? Guys, asa sa gipatuyok? Sa M1? Sa M2 or sa M3? Guys, wala ba naminaw? So kani gipatuyok siya along sa imong M1. Ang M1 nimo is aligned sa imong F1. Pag ipatuyok na nimo, so ang imong M2 ug ang M3 ang mag-change. There is rotation in M2 and M3 mobile frame. That's why naka-create siya diri og angle phi. Siya angle phi. And we name this as M2 prime and M3 prime na. Dili na siya original na M2 ug M3 na unit vectors. And there are three possibilities, no? Sa ingon ko pa, pwede siya sa i-rotate sa M2, pwede pa siya i-rotate sa M3. Okay? So, inani na itong formula, no? So, rotation 1, so pasabot along F1, no? And M1, no? So, na-notice niya diri na anay prime. Na siya prime diri. Okay? So, we're going to solve this one. So, nganong ang F1 dot M1 is 1 man? Because 0 man nilang angle dira, di ba? Pag ningon kag F1, M1, 1 mo na. Unit vectors, 1 naman na. Sunod ana is ang cosine. Cosine 0. So pila man ang cosine 0? Guys, kabalo mo at is cosine 0? So cosine 0 is 1. Ngayon mo na yung 1. Okay? Next is F1. Ilan sa ating F1 dot M2. Yun nila sa F2 dot M1. So F2 dot M1 is 90 degrees. 90 degrees siya, di ba? So kung 90 degrees na siya, the cosine of 90 degrees is pila man? Pila may cosine of 90 degrees? Cosine of 90 degrees is 0. 0 na siya. Okay? 90 degrees. Okay, so inaniyo na to para mas sayon siya tanawon. No? Kasabutan eh, kaning mo ang F1 is pointing upward. Okay, so madalas ko sayon siya. Pointing upward na yung F1. M1. So therefore, M1 and M2, ano 0 man? Tanawon na to kay M2. So ang imuhang M2, dere, no? And ang imong F1 is gatindog, pointing away sa imuhang plane. So kaniya to ang kuan, pare kaniya ano, pointing away sa kaning na plane na F2 and F3 na plane. So metabuana, that is 90 degrees and cosine of 90 degrees is 0. Then the repod F1 and M3 prime. So ang F1 nimo is pointing upward again, pointing away from the plane. Sa ang plane karon. So that is orthogonal siya sa imong M3. So 90 degrees again, so 0. As well as this one, 0, as well as this one. 0. Okay? The question is, how about the remaining na mga values? So let's start with F2, M2 prime. So ang imong F2 kaniman, kanito rin, ka-unit vector na F2. So dayon, ang imong M2 prime kani. Okay, so katong formula na to, that product is actually the angle between the cosine, the angle between the unit vector. So that is just simply cosine theta. How about kaning F3 and M2? Gano sine theta man siya? Okay, so mao na akong F3. Okay, then mao na ko ang F2. So the angle between F3 and F2 is, butang na to is beta. Beta. So beta, since right angle mo na siya, so beta is actually 90 minus phi. Okay? 90 minus phi. Okay? So kung solve na nimo, the cosine of 90 beta is, so bali ang sama ni nila beta plus phi is 90 man. So solve mo nimong beta, so beta plus is equal to 90 degrees. 90 degrees. So therefore, kung solve mo nimong beta, beta is equal to 90 minus phi. Okay? Then you're going to get the cosine of that one. That is actually equal to Sine na. That is property of trigonometry. Now, dali na punta sa F2. Dali na punta sa F2 dot M3. So, asa man akong F2? Mana akong F2. Okay. Then, mana akong M3. So, therefore, ang angle na ko karon is plus 90. No, cosine 90 plus phi. So, if you're going to take the cosine 90 plus phi, that is actually negative sine. Okay, so na may pangutana. This is just basic na trigonometry. Okay, so the same is true gapon sa kaning rotation along the fixed frame na tube. So ang gipatuyok na to counterclockwise ang ato ng M2, no, which is aligned with F2. Align ang F2 M2, that is what is known as fundamental. So align siya or fixed. Then ang imong M3 kag M1 na change. Okay? So para makita niyo ang nindot na angle, pwede na, no? So let us say, yun sa pagkuha ng sine phi. So ano sabi na siya? F1, M3. So F1, then M3. No, pareha na siya ganiya na property, beta na siya. So manang beta nimo is 90 minus phi. So cosine 90 minus phi is actually sine phi. Ano na pong negative? So negative. This is F3 dot M1. So F3 dot M1. Parehara. This is 90 degrees plus phi. So cosine 90 plus phi is actually negative sine phi. Okay? So kung di mo muto, ito try ko na. F3 and M1. Yeah. So, Google na to ng cosine is cosine 90 plus theta. So, kita nyo guys? Nakita nyo wala? Kita nyo ang cosine 90 degrees plus theta is actually equal to negative sine. So pag kuan po sa gito ganiya, a cosine tanto theta minus 90 minus 90. Kakili din. So ito plus mag-gapon siya. Cosine 90 minus theta. 90 minus anyway, ato ra. Adili sa na sign man siya na cosine na cosine. Salay na to ni cosine. Adili niya magkuha ang minus cosine. Ay na lang ba ito Wolfram this. Makita niyo guys ang Wolfram no sa balik cosine. Buta na to. Theta. Phi man to no. Cosine. Ilang word lang eh. Input. Cosine 90. 90 minus problema ni degrees. It should be pi over 2. Isod naman siya. Pi over 2 minus sige, punta na ito C. Automatic change na ito ni. Mana siya? Cosine pi over 2, mana siya 90 degrees. It should be converted to radian by default. That is sine phi. Okay? Anyway, balik na sa ito ang kuhan. Okay, so na may pangutana. Ilumod mo kayo mo basta try ko lang studiyahan. But don't you worry, ginaman mo assignment. Mapugos kita mga negat. Okay? So the same is true if you're going to rotate this along M3. So mga yan lang mga values. Okay, di na ako elaborate. Balik-balik lang si cosine, si negative sine, sine, cosine. Okay? So ang importante lang is you draw it on a plane na one perspective para dili lisod tanawan kay pag 3D magud siya, 3-dimensional. Sometimes malimot ka, uy 90 degrees man din na sa M3 o sa M1. Ang ginagawa na. Okay? Dire at least makita mo siya. Okay, so dire natin sa inyong assignment. Your assignment is you're going to draw. Draw katong gipang-draw na to. Natuon pag-draw and solve the fundamental rotations of every axis with clockwise rotation. So take note, clockwise. Ganiya, it's counterclockwise. Counterclockwise man karon, it's clockwise na, baliktad na sila tanan. Then you're going to compare. Now you're going to answer this question. Compare and differentiate the results with counterclockwise. Okay, nakasinabot na sa inyong assignment. Mura na nimo na siya i-redo. I-redo na nimo sila tanan. Except that, dili na siya counterclockwise. Dapat clockwise na siya. The same in the movement of the clock. Okay, so same lagi po ni mong buhaton. Magkuha na ka na. Inana ka na view or inana ka primero ng later para ma-solve. Okay, so kaning sa taas, drawing and solving. Kaning sa kadua, it's explaining that one, comparing the results between clockwise or counterclockwise and clockwise rotation. Okay? Nakasinabot na sa inyong assignment? Ano may oras?
sir.
Magalas dos. Okay, so let's proceed, no? Homogeneous coordinates. Okay, so we need few rotations and translations to characterize the position and rotation of a point relative to the coordinate frame attached. So this is what is referring to the homogeneous coordinates. While a rotation can be represented by 3 by 3, kato ganiya 3 by 3 naman to siya, it is not possible to represent these homogeneous coordinates or translation by the same. No? So may mo na siya four-dimensional space na siya, or what is known as the homogeneous coordinates. Okay, so magdugang na tag isa ka row or column sa imong matrix. So definition, let Q be point in the dimensional space R of order 3. So pasabot 3 coordinates, orthonormal na coordinates or 3 axes. And let F be an orthonormal coordinate frame of the dimensional space R3. So if the sigma is any non-zero scale factor, then the homogeneous coordinate Q with respect to X is denoted as NA is now sigma Q1 comma sigma Q2. So upat na sila. Okay, upat na. Dayon, in robotics, for simplicity, you just use sigma is equal to 1. Ano na presentation. Okay, so if a physical point in 3-dimensional space is expressed in terms of its homogeneous coordinates, and we want to change from one coordinate frame to another, so we use the 4x4 homogeneous transformation matrix. So, mana na siya, mana itong istoryahan ng transformation matrix. Well, the R is now the itong ganiya atong fundamental rotation matrix. So P is the vector. P are it's a 3x1 translation vector. Eta is represented is a perspective vector usually set to 0. Then the sigma, auto ganiya is by default is equal to 1. So kani siya, in terms of the robotic arm, P is the position, the TCP, and R is its orientation. So dili ni katong R cube ba? Katong R na katong yang rotation. Rotationing R, okay? Rotation ng R. Then ang ganing P ni mo, it's in the translation, and rotation. As well as the orientation. So yeah, it's the rotation. Okay, so the fundamental operations of rotation and translation can be each regarded as special cases of 4x4. Balik-balik ka, para di mo kalimot na 4x4 yun na siya. Homogeneous transformation matrix. So inani na siya. So it is a function of the rotation as well as the coordinate na so mga na ni yung mga na yung fundamental rotation nila 0, 0 nagsabi 0, 0 mga na yung sigma nila. Okay, so this is now what is known as the Kate fundamental homogeneous rotation matrix. Okay? So pag na-word na homogeneous, ma-4x4 siya. Pero pag fundamental rotation lang, 3x3. Yun mo na siya. Okay? So ang translation ko din mo, the same is true. No? 4x4 gapon siya. Pero kani siya, since wala may rotation metabo, this is what is known as identity matrix. Identity. Okay, kanang identity kung sa scalar value pa na siya, mura na siya 1. But since this is a matrix, it's the diagonals of 0 of 1's. Identity matrix. Okay? And this is what is known as fundamental homogeneous translation matrix. So if T1, this is referring to your F1. F1 fixed frame. Pag diripod, it is referring to your F2. F2, example kani F2. Then pag P3 is a fixed 3, F3. Example kani diri. Okay. Then TikTok diri kay mga sa sigma. Okay, so inverse homogeneous transformation matrix. Actually, masolve naman ang imong inverse matrix. But in terms of the values of R, fundamental rotation and translation, ano yung formula. Okay, nana siya transpose ni mo yung mga matrix, then diri kay i-multiply ni mo ang negative transpose in mga translation of P, and 0, 0, and of course this is the sigma, which is equal to 1. So 0 ang ato ang diri. So we go now to our last 3 slides before we end. Kina na may kuan composite homogeneous transformation. Say composite is combination now of the translation and rotation. So in this example, for the sequence of actions, translation of M along the fixed frame, second fixed frame na axis by 3 units. And then it is being rotated about, the mobile frame is rotated about F3 by 180 degrees. Find the composite transformation matrix. So, mao niya to ang notation, the transformation matrix. So, mao niya katong sa rotation, 180 degrees dahil kuan fixed frame 3. No? Third, fixed frame access. Dahil natong translation, trans by 3 units along the fixed frame 2 axis. Okay? So, mura ginani guys, sa rotation, 180, then 3. So, mano yung mga rotation din. Fundamental rotation. So, kadumdum pa mo, if it is along fixed frame 3, by default, it is counterclockwise. So, kadumdum mo ganiya, ano siya na value. Okay? So, ano siya? The last example. And of course, the 0, 0, 0, 0. Okay? Then for the translation, so this is the unit or identity matrix. So, identity na niya. Dito na mo siya. Dahil it becomes 0, 3, 0, 3. Anong deriva ng 3? Because daaram siya sa F2 by 3 units. So, ano siya? So, mas madali na lang ni siya kay naka-matrix na form. Wala na trigo-trigo ano ya. Na-trigo na to ahead of time. So, ganiya. So, mura ginahan din siya ng example. No? This is your mobile frame. Ipa-move siya 3 units sa F2 ni mo na kuhan. So, move forward na siya to the right. Mamaya ito F2. Okay, mura ginahan. Then, rotated by, so kanimong mobile frame rotated about F3 by 180 degrees. Makita mo aning dash, dash, dash. Tuyok na siya dito sa Picas. Okay? So, time naman, nasa ko meeting, na mo'y pangutana. Okay, so attendance. Kung wala ka attendance mo guys. Dahil magkuhan siguro ta. Screenshot. No? Pwede ipakita niyo yung camera. So, can stop recording. Last na.